Hello everyone. Welcome to another edition of Cambridge A-level question. A quick one. Um, there's a minor correction I observed on one of my last video, mechanics paper 4-2, May June 2023, number 5 particularly. I made some minor error there. The diagram was the skeletal diagram was perfect, but I mistakenly ignored one or two arrows which I want to quickly correct. Mechanics paper 4-2, May June 2023, number 5. This is it on the screen. Okay, now the question is this: a particle of mass 0.6 kg, as you can see, the particle is placed on a rough plane which is inclined at an angle of 35 degrees to the horizontal. The particle is kept in equilibrium by a horizontal force of magnitude P Newton acting on a vertical plane containing the greatest slope. The coefficient of friction is 0.4. Find the least value of P. Now, when you check the diagram, like I did in my last diagram, you can see the force P is not properly placed, it's tilted. So it will maintain the same angle 35. So we are going to resolve the P vertically and also horizontally. That's the whole idea. When it's up, so at an angle of the same angle that maintained the inclined plane, 35. So when you resolve it vertically, so you're going to have P sine 35. Horizontally, this is the horizontal part. You're going to have P cos 35. You can see the direction in which the horizontal is going. When you resolve the particle normally on an inclined plane, this is the weight. The weight is mg. Resolve it vertically. Here will be mg cos 35. Why? This side will be mg parallel to inclined plane will be mg sine 35. Now, since the direction of the particle is going down the inclined plane like this, is down the inclined plane, so frictional force will oppose it. Frictional force always oppose motion. It goes in that way. So from here, now frictional force opposes motion, and remember at the same time that normal reaction is like this. Okay, since the question said is in equilibrium, upward forces is equal to downward forces. The upward force, that's the normal reaction. This is one of my mistakes in the last one. The downward force are P sine 35. If you check it, is going downward. What else is going downward again? Mg cos 35. That's one of the mistakes. So from here, so normal reaction will now be, what's our P? We don't know. P sine 35. What's the mass? The mass is 0.6. G is 10 times 10. Only have 6 cos 35. This is the first equation. At the same time, when you check the motion along the inclined plane, the frictional force is going in this direction. P cos 35 is also going in the direction of frictional force. So when you follow the direction, frictional force plus P cos 35 will be equal to mg sine 35. Look at mg sine 35 is going in the opposite direction of these two. That is how you resolve it. At the end of the day, frictional force will be mg sine 35 minus P cos 35. What's our mg? Mg is 6 sine 35 minus p cos 35, equation 2. Now, since frictional force equal to coefficient of friction times normal reaction. Of course, you know the reason why there's friction. The surface is rough, as stated in question. What's our frictional force? Equation 2. Our frictional force is 6 sine 35 minus p cos 35 equal to coefficient of friction is 0.4. Our normal reaction from equation 1, normal reaction is p sine 35 plus 6 cos 35. So now let's do our math. Okay, 6 sine 35 will give us 3.4415 minus p cos 35 will give us 0.8192p equal to 0.4 multiplied by p sine 35. That gives us 0.2294p. 0.4 multiplied by 6 cos 35. That's 1.966. Collect the like stem. That will be 3.4415 minus 1.966, so equal to 0.2294p plus 0.8192p. So let's do the subtraction. 1.966. Here we have 1.4755 equal to 0.2294 plus 0.8192. So we have 0.2294 plus 0.8192. So we have 1.0486p. So make p the subject formula. 1.4755 over 1.0486. So p will be 1.4755 divided by 1.4755 divided by 1.0486. So our p is 1.41. Remember the question said that find the least value of p. So the minimum value, that's the least value of p, this is the least value, which means p can be greater than 1.41, but the minimum for the body to move will be 1.41. That will be the answer. Thank you. Please subscribe to my channel. This month is going to be loaded. I have a lot in stock. I'll see you in the jiffy.